Okay. Thank you so much, guys, for joining us today. This is our 10th Flutter webinar, and today we are hosting Isaac Messier. So Isaac is a software engineer at Diaspora AI, and he's also a technical speaker and a technical mentor. He's been speaking on giving sessions, code labs during our meetups and sessions, and he's also one of the he's been helping us a lot, especially in this Flutter Kenya group. Whenever anybody posts a question, whenever anyone is having an error that needs to be solved, he's been helping us a lot. And we are really glad. He's also an open source enthusiast. And today we'll be talking about asynchronous programming in that, and we are really thrilled and honored to have him. So Isaac, feel free now to take over the session. Thank you.
Okay, thank you, Candy, for this opportunity. And thank you, Danvik Latu, also for introducing us. So, hi guys. I hope everyone is doing okay and keeping safe during this pandemic. So, like my colleague said, my name is Isaac Mutier, and I'm a software engineer at Diaspora AI, but she has already introduced me, so I won't go much further into that. And today we'll be talking about asynchronous programming with Dart, and just like it's highlighted, mostly it's just an introduction part. So maybe before we start, I can point some things out. So this is the first one in a series of sessions. So I've talked to the organizers, and since it's a very wide topic, we'll do it in sessions. So the introduction part is split into two. So today we'll be looking at isolates and event loops. We'll also have a look at Dart features and streams. Then on the next session, we'll be looking at the async and await keywords on hand, how we can effectively use them. We'll also have a look at generators and also have a look at background processes in Flutter. And that will now complete the introduction part. And then next on now, we can start now digging into the specific asynchronous APIs. And now we'll start doing code labs and exhausting them further till we understand the topic. Yeah, so without much ado, let me continue. So when we talk, before we even start talking about asynchronous programming, so let's first talk about synchronous and asynchronous programming. So these terms, I'm sure, especially coming from languages like JavaScript, these are terms that you have come across very often, and sometimes they tend to confuse us. Sometimes we don't know what they mean. So before we start, we can have a look. And with me here, I have some code snippets, but let's start with synchronous programming. So when we say that something is synchronous, what we mean that it waits for an event to happen before continuing. In other terms, we call it like a blocking process, sorry. So it blocks other things which come after it from operating until it finishes executing. And then until then, it gives room now for the others to continue. And looking at the Dart snippet at the right of my screen, so this is just a small snippet that it prompts the user to enter their name, reads it out, and then display it on the screen. So it's not fancy, but it helps me a lot in like showing what exactly is we mean by synchronous programming. So there is this Dart API, the standard in.readline sync. So this is just a method to wait for user input. And like I've said here, it stops in its tracks and does not execute anything further until it receives the user input. So the moment you run this piece of code, it will prompt you to enter your name, and it will block any further lines. So on our case here, the other line, the other piece of code that is waiting to be executed is the print statement. And there is no way that is executing until the read line sync has finished executing. Until it has taken the user input, it cannot allow the other now code snippets below it or the other code block to be executed. So that's what we mean by now synchronous programming. So it's, in other terms, blocking code. So as execution of anything that follows it is blocked until it finishes execution. Yeah, so continuing, and the main disadvantage of this mode of programming is, especially in cases where the code takes too long to execute, the subsequent blocks will be now blocked from executing. And most of the cases you might find that even those, they are not even related to the part of code that is currently executing, but they will be blocked until the current piece of code block is finished executing. Yeah, kindly mute your mic until you have to answer a question, please. Thank you. Yeah, so that's just it, the basic of synchronous programming. In simple words, we have said that you can call it, you can term it as now blocking code. And now moving on to asynchronous programming. So an asynchronous operation executes in a thread, which is actually separate from the main application thread. But now put in a simple term, like what we've been said about synchronous code, asynchronous programming operation is a no waiting or non-blocking programming model. And what do we mean by this? So, for example, when an application calls a method to perform an operation asynchronously, so the application can continue executing while the asynchronous method performs its task. So looking at this disadvantage for synchronous programming mode that we saw above here, where now all the code blocks have to wait for the current code block to finish executing, on asynchronous programming, it's the other way around. Like there is no any blocking that happens. So a current piece of code is running or a process is running, but still the application can allow other any piece of processes, other pieces of code blocks to run. And when this current process finishes executing, then its value will be processed now in the future. I think we shall look at that later. So basically, asynchronous programming is the no blocking programming model, where now other processes can continue running while the current one is still running, especially for the ones that take a lot of time to complete. Yeah, so that was async and sync programming. So allow me to use the words interchangeably, just shorten the word asynchronous into async. And that was just the general overview of them. But now let's look at them now from a data perspective. And all of us here are doing Flutter. That means in one way or the other, we've interacted with Dart. And as we know, Dart is a single-threaded programming language. So everything runs in one thread. And if any code blocks the thread of execution, like for example, waiting for a time-consuming operation or blocking an input-output system, so the program kind of effectively freezes until that operation finishes. However, so that offers support for now the async APIs, the one that we are going to look in this session. So mostly they are features, they are streams, they also have background processes or background work, and like all the other things, all the other async APIs that we need to write in a synchronous and reactive way, like especially when we are working with Flutter. And our first items in the list are isolates and event loops. So because these two form the foundation of that support for background work. So if you understand how isolates work and if you understand how event loops work, then understanding the other higher APIs like features and streams, then they are not going to cause you any problems, especially the event loop. It's very key to understanding features and streams. So let's look at isolate. And just hearing the word isolate, you can even start thinking, since it's almost a self-explanatory word, that means maybe setting aside, but looking at it now from a programming perspective. So all that code runs on an isolate. So like how now that executes its operations. So when you talk about an isolate, we can term it like just a little space on the machine with its own private chunk of memory and a thread running an event loop. Remember, we talked about an event loop, but we shall look at it still sometime later here. So that's how we can look at an isolate. It's a space with its own private chunk of memory and a single thread running on an event loop. So as you know, many data apps run all their code in a single isolate, but definitely there are cases where maybe you might need to create another thread or another isolate. So maybe you are performing a very time-consuming operation or an operation that requires a lot of resources. So if you have a computation to perform that so enormous and it could cause issues if it were run in the main isolate, for example, it could even cause the app to freeze. Then you can create a separate isolate to do the crunching, and you can use either the data provided API of isolate.spawn or Flutter even provides a compute function, but like I said, that those would be topics for another day, but I leave a link in case you want to look at more on that. So the new isolate that you've created gets its own event loop and memory. Remember we said an isolate is more like a little space on the machine with its own private memory and a thread running an event loop. So the new one you've created also gets its own event loop and memory, which the original isolate, the parent isolate, now isn't allowed to access. So looking from the word spawn, like this new isolate spawns from the parent isolate, but still it isn't allowed access to that. Hence, that's where we come with the name isolate, like they are kept isolated from one another. So the only way that these two can communicate is by passing messages back and forth. So one isolate can send a message to the other through a specific port, and it can also receive message from the other isolate using its own, like they can send messages, and the one that received the message, it can process it using its own event loop, since each isolate has its own memory and also has its own event loop. So this is more of lack of shared memory, especially coming from languages like C++, where parallelism is a thing. Like this may sound new, but actually when looking at that, it's an advantage because of memory allocation and garbage collection in isolate. They don't require locking. So since here it's that, and we are only working with one thread, and if it's not busy, then we directly know that now the memory isn't being mutated anywhere. So coming to Flutter, this is where the main advantage applies, and sometimes we need to build up and tear down a bunch of widgets very quickly. So if you know how Flutter operates in the background, which is also a topic for another day, then the lack of shared memory here really comes handy, especially when it comes to garbage collection and tearing down those bunch of widgets which are no longer needed. So the advantage of this lack of shared memory, like working in different isolates, really comes handy. So that's almost all about isolates. I leave a link if you want to learn more, and maybe, like I said, in future sessions, now we shall look into isolates at all and try to create some. But we have been talking of event loops, and what are these event loops? And they are what make the asynchronous code possible. And some earlier on, I said, if you are to understand futures and streams, if you understand how event loops work, then futures and streams are not going to pose any problem for you. So this is how an event loop works. So in case like, in order to understand it, so imagine the life of an application stretched out on a timeline. Like every day we use apps on our phone. Like just imagine any app, the app that we created, the app that we use every day. So the timeline starts when you open the app and it ends when you close that app. And in between, you can bear me witness that there are a lot of things that happen there. So sometimes you are reading data from the disks, you are clicking on buttons, you are tapping on links. A lot is going on during all that during that app cycle. And since the app can't predict when these events will happen, and importantly, it doesn't even know in what order. So it has to handle all of them with a single thread that never blocks. So one of them should like never block the other. So we say that the app runs on an event loop. And what does this mean? It means that the app grabs the oldest event from its event queue, processes it, and goes back for the next one, processes it, and so on until the event queue is empty. So in simple terms, suppose like now you are doing a bunch of things there. Maybe you are making a network call, you are tapping some other buttons. So what happens here, every event you do during that app cycle is put in a queue, and all those are run through the event loop. So the queue takes the oldest event that you did the first one, it processes, it goes back for the next one. After processing it, it goes back for the next one until the event queue is empty. So, like I said, all this time the app is running and you are doing all those things in the background, and the event loop is just going round and round, processing the events one at a time, and until when there is a break in action, there is no more event in the loop, and the thread hangs out, just waiting for the next event. And sometimes even this is the time for now the thread to trigger some actions like garbage collection during when it's idle. Until now, another event pops out in the queue and it runs through the event loop, gets picked, gets processed, it gets dropped, and the event loop now goes on to wait for now the other event in the queue. So I guess that depicts now like what exactly we mean by an event loop. Think of it like a wheel. So there is a starting point, and like now the events, they are more like in a very crude example, like now people lining up now like to get into the wheel, or you can take the people now as the events, and they do so on a first come, first served basis. So the oldest one or the earliest one which got there, it gets processed. The wheel is still spinning and processes that, drops it, goes, picks up the next one, processes it, and that goes on until now there are no events in the queue anymore. So we say now that the thread is just hanging out. And now, looking at now the async APIs now, the futures, the streams, like, and all other, the async data APIs, like we said, they run on the event loop, and let's start looking at some of them. So maybe before I do that, now you can find some resources, especially on isolate and event loops. I think I leave this one. So these provide very detailed information when you want to understand them further, and I'm sure keep keeping on. So yeah, maybe we go to futures, and I don't know if up to that there are any questions. So if there are any questions, then you can talk to Jacqueline Kendi. She's in call, then she can handle it, and she can pose the question, you can answer, and then we can move forward. So don't be left out, please. Now, let's go to futures. And this is a very important topic, especially when dealing with now, a framework like Flutter. I'm sure almost everyone here has worked with Flutter, and we have dealt with futures almost everywhere. Sometimes we use them and we don't even know what they mean. And sometimes even you don't know that you've used a future, because working with frameworks, it has now abstracted almost the deep things for you, and it allows you to work with the outmost APIs. But in one way or the other, we have interacted with futures. So what exactly is a future? And yeah, I know we talk of futures in daily perspective, talking almost about everything. But when it comes to futures now from the perspective of now programming, we can say that a future is an object representing a delayed computation. So it's something that will happen in the future. So it is used to represent a potential value, or it can also return an error that will be available at some time in the future. And receivers of a future can register callbacks that handle the value or error once it is available. So what are these receivers that we're talking about? Because if a value is to be present in the future, then it needs something else to be able to use that value, to process that value. So that is what we call now the receiver of the future. And let me give you an example. So this example was given by Andrew broke down in Flutter Focus, if you people are aware of it. So suppose you have a gift box. Somebody gives you a gift box, and that gift box comes in some states, like it's a wrapped box and you actually don't know what is inside. So he used it to represent what we mean by a future, and also like the states of a future that we are going to look in a very short while. So imagine I hand you over a gift box, and the gift box is closed initially, and you expect inside to be something. So you expect inside to be something, but not exactly one thing. So you either expect a good something from it, or once you open the box, then something else can go wrong. I mean, I don't know what could go wrong with opening a box, but you get the point. Like now, the box starts with now an initial state, which is it's not closed, but there are contents in it which will have access in the future. And the contents can be either in the correct form that you expected or in another form that you didn't expect. So let me put it in that way. So that's a good way to represent a future. And like I'm saying here, a future is one of the simplest and most basic data APIs that has for async programming. So remember the 3 states I was talking about when we were talking about a gift box. And now let's forget about the gift box a bit. So a future can be in 3 states. So it starts out in the uncompleted state. Now you've just now like initialized the future. You've just registered the future now. It hasn't computed, so it hasn't completed, it doesn't have any value or any error. So the future, we can even say that it exists in 2 states. The first one is uncompleted, but the other one now is split into completed with a value or completed with an error. And when in programming you are to deal with futures, then you need a way to be able to handle these 3 states. So when the future has just been registered, it's uncompleted, when it completes with data, and when it completes with an error. And if I could relate this to the gift box that we just talked about, so it all starts out in the closed state. We can call the closed state of the box as uncompleted. And once you open the box and then just making an assumption then that you might find maybe a good pair of socks inside, maybe we can call that completed with data. Like it's what you're expecting. It's something good, like you are expecting a gift and that's what you got back. But also you can open the box and things don't go as you expected. Like I said, I don't know what could go wrong with that, but we can relate that to now like completing now with an error, and it also needs a way to be handled. So let's elaborate our future further, and I have myself a code snippet here, and mostly it's now picked from our Flutter code. So we all know of a raised button. So suppose now you have a button, which when you tap the button, it starts downloading a picture, either mostly through a network call or whatever. So first, the tap event occur. So remember the event loop, what we said, like the event loop handles events as they come in the queue. So once now the state has initialized, so and you now begin your event. So the first thing you do is tap the button. So the event loop gets the event and it calls the tap handler. So the tap handler is what you have registered with now the onPressed parameter, like what happens when I press this button. So the handler now, which is the callback, it uses the HTTP library to make a network request call. Then now the HTTP will get, and it gets a future in return. Like, as you can see now from my snippet here, like it returns a future from the network call. So you have just registered the future, and you know that this future will complete some time later. So what do I do when this future completes? And remember, this future can either complete with the image or it can complete with an error. So you need to handle that. So what you do here is like to process what happens when the future now returns, you register the .then callback. So this is what we call like now the receiver of what we call the receiver of the future. So it's what receives the value that was returned in the future. So what happens when the future completes is registered use the .then callback. And you can see from the screen that our .then callback, it calls some set image and passes in the response, which is the future that we got from our network call. And now, yeah, I just introduced that early. So working with futures, right? This was just a basic example of like the life cycle, the cycle of a future, like what happens. So you press the button and you register the future, which gets or calls a network call and returns something in the future. In our case here, it should return an image. And then what happens when the image comes? Remember, like the future, the image will be available sometime in the future. Other code is still executed. So when the image comes, Flutter knows that now there was a callback, or that knows that there was a callback that was registered for the receiver of this future. What I'm supposed to do with it? I'm supposed to call a method called setImage and pass this image that I got. And basically that's the value, that's the cycle of how her future works. And now, like most of the time, especially working with Flutter, you won't have to use futures directly. And on very few cases would you be required like to create the future like itself. And like I said, most of the time we've interacted with them and we even don't know, because they already have libraries that generate features for us. And just like we saw in our previous example, the network call, the http.get, it returns a feature. This is available that this is just something that happens in the future, whether you are fetching JSON data, whether you are calling an API, returning some user data. So all these return features, this is data that will be available sometime later. Also, if you have worked with shared preferences, and if you listen to my previous talk on Flutter, we talked about shared preferences for data persistence, and we made use of this. So the shared preferences also, its instance returns a future because it's something that will be available after some times. And these just are the libraries that create the features for us. But now remember, you can also create features by yourself. And there are several ways you can create features, but like I said in the beginning, so that will be topic for another day. So the most basic way here is to use the feature constructor. And the feature constructor, it takes a function and returns a feature that matches the function's return type. And later the function runs asynchronously and the feature completes with the function's return value. So let's look at the first code snippet here, the one on the top, the main function on the top. So here I've instantiated the future constructor. So I've called it my future, and it takes an anonymous function. So let me just use the curly braces format for learning purposes, and it returns at 12. It returns 12. So the type of this future is determined by the return type of this callback. So the function inside the future constructor is the one that determines now the type of the future. And since we are returning 12 here, we know that our future is returning now like a future integer. So in the future, we're expecting some integer, which here will be 12. And then we need to register a receiver or a callback that will handle that future. And like we said earlier, the .then callback is the one used to handle like now when the future returns with a value. So like I said here, so like you can see my future.then, which also takes a callback. Like this callback is the one that represents what is to happen with this future. And it's expecting an int. So if you return a string here and you pass an int here, then definitely it's going to give you some problems. So remember the type is now determined by the return type of the future constructor callback. And since we are returning an int, the .then callback, it also expects an int, and here we just print it. So we shall look at this when we get now to the code lab sessions where we'll be working, where we'll be creating now the futures. But here, as you can see, like this is how you create a future of your own, and you register the callback to process the future. And like we said, those are just the two states. The first one, the uncompleted states, and then the completed with a value. But remember, there is also the state where the future can complete with an error. And we also need to handle that, right, for effective programming. So a future can also return an error when something goes wrong. And just like we use the .then callback now to process what happens, to register what happens when the future completes with a value, the catch error callback now represents the receiver for what happens when the future returns with an error. And to demonstrate that, let's look at my second code snippet. It's still the same piece of code here, but then instead of returning 12, as you can see, I'm throwing an error. So it's just guaranteeing that the future will return with an error. And actually, now here we register the two callbacks. So this is called method chaining. So you can use my future.then to register what happens if it returns with a value. And then you can chain the .catch error callback to register what happens when the future returns with an error. So just like the .then callback receives the value, also the catch error receives an error, and you can do whatever you want with that error inside that callback. And again, when you get to the code lab session, then we can explore this further. And then there is a note here that you don't need to call .then or .catch if you are using the async await language feature. So our fourth API in this session is async await, and we shall talk at this when we get to that session. But especially here talking of Flutter, like most of the time we have found ourselves interacting with just async and await. And mostly we don't use the .then or .catch error callbacks unless when necessary. So instead, you just await the completed value and you use the try catch and finally handle errors. And to some extent, even the final is not used to some extent, but the try catch block can help you now catch errors from the future when we use now the async await language feature. And I think we shall talk about that more later when we get to the session. And that was just basically how to create features. And after creating features, how to register the callbacks when to handle when the future returns with a value, and also to register the you use the dot catch error callback to register what happens when the future returns with an error. And let's move on. Now, let's move on to using futures in Flutter. So where we've almost dwelt, and say we have a network service that's going to return some JSON data here. So the JSON data will have some fields, and we want to display that data. So there are two ways we can approach this. And one of them will be just our basic way of using the stateful widget. And that's just, we create the future, we check the completion or error, and we call the set state method and generally handle all the wiring manually. So that's when to do that. And the other way is using a widget that comes with the Flutter SDK known as the future builder, just like we have used in our code snippet here on the right, if you can take a look at it. So we are giving it a future and a builder function, and it automatically rebuilds all its children when the future completes. So it also has the 3 states, so the incomplete state, and when the future returns with a value, and when the future returns with an error. So the future builder widget works by calling its builder function, like you can see here, sorry. So the future builder widget works by calling the builder function. So the builder function takes the current context and the snapshot of the current state of the future. So as you can see here, it's a future builder and it expects a stand. So this is just the type annotation. So here we expect the future to be of type string. And then we register the future here using the future property. And it's just some network call that fetches the JSON data, as you said. So the fetch network data is just a dummy method that fetches the network data. And then the builder function, this is the one that is called. And like we said, it takes the context and the snapshot of the current state of the future. And let's handle, here we have to handle the 3 states of the future. So we can use the snapshot to check whether the future has completed with an error or a value using the has error property or the has data property respectively, and then handle them accordingly. So for example, so here we have said that the snapshot represents the current state of the future. And if the snapshot has error, or if the future has returned with an error, we use the snapshot.error and now do whatever you want to do when the future returns with an error. In our case here, it just returns a text widget that says there was an error. Else, if the future returns with a value, that's when we use the snapshot.hasData property. So the snapshot.hasData is a Boolean that returns true when the future returns with a value. The has error is also a Boolean that returns true if the future completes with an error. So there then we do like, we register the receiver that is now to process the future value. And this just to decode the JSON data that comes in. And also we have the third state. Remember we had the 3 states, the uncompleted, then completed with a value, and then completed with an error. So if neither has error nor has data is true, then we know we are still waiting, we are still in the uncompleted state, and we can output something. So then here we output the text of no value yet. So if you were to run this in an app, and in case you are wondering which comes first and which gets processed when. So initially, remember, we start with the uncompleted state. So the future neither has data nor has error. So it's still in the uncompleted state. So here, the first thing to be displayed will be the text widget with no value yet. And when the future completes, depending how it has completed, so if the future returns with a value, then it will rebuild its children. It will call now the builder widget, and it will rebuild now the widget tree with this text here. So it will replace this text of no value yet with the text for JSON decode, now with the JSON decoded value. And if the future returns with an error instead, it will also rebuild the widget tree, but then this time it will replace the no value yet text widget with the text that there was an error. So that's generally how now the future builder works. And I think it has signified like what we talked about how futures work. So initially we register and we wait for it to finish. And once it finishes, then we process that value. If it returns with an error, we register the callback that handles the error. And if it returns then with a value like we expected, then we register now the receiver or the callback that handles when the future returns with a value. And that's all about futures. Definitely not all, but it's basically what we are looking today at futures. And if you want something more on futures, then you can look at a few resources that I've shared here, and we can also look at them later when we get to the code lab sessions. Let's move on to the next Async API that provides that. And this far, I hope everyone is okay and there are no major questions. In case then we at the end of it, we leave some few minutes then for questions, but let's move on to streams. And okay, talking on my behalf, I don't know about you, but streams, I can say streams are quite one of the most complicated parts. If you don't understand them, when you're talking about now the data synchronous APIs, streams can be complicated at first, and you need to first work with them so that you can understand like how they work. But once you understand how they work, since they come very, very handy when working in different processes, like depending on your needs, they are just like the futures, they are one of the core implementations of that async support. And what are streams anyway? So remember when we talk about streams, streams provide an asynchronous sequence of data. And talking from the literal meaning of a stream, we know a stream is just water which is flowing. So the water just flows continuously. We can say, in other words, like it just flows in a sequence and it keeps flowing, it keeps bringing in some water. So that's what we can also use like to elaborate the stream. So it provides an asynchronous sequence of data. And when we talk about data sequences, then we can include then user-generated events, maybe the events that you do that now require a sequence of data. For example, when you're creating a number creator, maybe you have a number creator that should return a value maybe after every 2 seconds, and it runs infinitely, then we can call that then a sequence of data. We can call that a data sequence because it keeps flowing in, it keeps bringing on values, and you process those values. And also, especially the most basic implementation of streams is when reading data from files. And we all know that when working with Flutter or Dart, it reads files using chunks. So it reads them in chunks of streams or chunks of data. So it reads the first chunks of data, it puts them, processes it, it reads the other chunk, it puts it away for processing, and just like that. So it's like now you are receiving a data sequence and you can process that now accordingly. And when it comes to processing that stream, there are several ways you can do that. And for now, we are going to talk about 2. So, I'm looking at my time, make sure that we are not that far behind, but we're almost wrapping up. So you can process a stream using either the await for loop. we shall look at that later, or the listen from the stream API. So the stream API also provides the listen method, and we are also going to look at that very shortly. And before we do that, let's look at some similarities and differences between a feature and a stream. So they are similar actually in one way or the other, and in that they both work asynchronously. So they are both async APIs, like they can allow some other processes to go on while they are still executing. And just like features, they also return some potential value, as well as providing a way to respond to errors, because just like features, they can also return a value as you expected, and they can also return an error. And however, there comes the main difference. A feature has only one response. A feature can return with either a value or an error, just that, while a stream could have any number of responses, and we shall look at that later on, we shall understand it better. So we could say that a stream is a combination of features, since remember it's a data sequence. So every data sequence can be coming as a feature. So those are all future values that are coming. So you are expecting an infinite number of future values that are coming in, that are streaming in, that will process at a later time. So we could say that a stream is like a combination of futures. They are just a bunch of future values that will come sometime later, or some errors that will occur sometime later, and we'll have to process that. So there are two types of streams. There is the single subscription stream. So these streams, they have a maximum number of one listener. So they can only have one listener, and if you register another listener for them, then it's going to throw you some error. Sorry for that. Yeah, so maybe to elaborate on this and what we mean by listeners. So when you talk of streams, remember we said that they are bringing in data sequences. So we need a way to process that many sequence. Remember what we said when we were dealing with futures, that yes, a future returns with either a future value or a future error. And we register receivers for those values. We can use the .then method to register a receiver for when the future returns with a value, or use the .catch error callback to register a receiver when the future returns with an error. So the same case applies for streams. So in this case, we call them listeners. So all that data sequence that is coming in, you listen for it, or you can process it. And when we talk about single subscription streams, so we mean that there can only be one listener for this type of stream. And if you try to instantiate any other listener for it, then it will throw you some error. And today we'll be looking at that single subscription stream. But another thing, this one, we shall look at it later, they are the broadcast streams. And this means that there could be infinite number of listeners to this stream. So that's why they are called broadcast streams. And once you register them, then you can register any number of listeners to listen to the values or errors that come in and process them accordingly. So let's go to creating and processing streams. And streams can be created in many ways, like very many, and I'm sure we shall look at it in now the next sessions that come. But the most basic way is using the periodic API provided by the stream API. So just like you can see in my code snippet right on my screen. So here I'm creating a stream, and I'm using the await for loop, the asynchronous for loop, like we talked some time ago. So this is how we create a stream, and a stream also has a feature value, and that value also has to be of a certain data type. And this time we can annotate it to an int. So we can create an int stream, and what this does is that it emits event at period intervals. In our case, it emits a number after every seconds. So this one starts at 0. So after every 2 seconds, it will be emitting a number, and we are going to process that number. So it starts at 0 and it goes on, it goes on, it goes on, it goes on infinitely. And the periodic one takes 2 callbacks. So it takes 2 parameters. The first one is the duration. So this is just one way of creating a stream. Definitely there are other ways that we look at them in some later sessions. And for purposes of understanding, creating and processing streams, so this is one way of creating a stream, and we are using the stream.periodic method, and it takes 2 parameters. The first one is a duration, like after how long should I emit a value? And then a callback that registers what to do, like what value to return. So you can just return the value, or you can do some processing and then return it. So just like the future constructor, remember the future constructor also was expecting a callback that now returned the value to be returned by the future. Same case to a stream here. So it's of type int. We are returning int value, and we are doing some process to it. Just add 1 and multiply by 2. Just some fancy stuff. You can do whatever you want with the value. And then we need to process this stream. And one way of doing so, like we said, is using the await for keyword, and it's called the asynchronous for loop. And before I continue, I need you to think of a stream like an iterator. So it's more like a list. Let me call it a list, or in better words, an iterator. So the way now we can talk about now the into values, the numbers, and then be contained maybe in an iterator, like we have a list of 10 numbers, we can think of streams like now an iterator containing futures, some future values inside it. So in order to process those values, we actually need to loop through the stream. So remember, the stream is returning a sequence of numbers. So it's a sequence. It returns, like this one that we have registered here. If we were to run this for 20 seconds, so we are actually expecting 10 different numbers here, since it runs after every 2 seconds. So that's like a list of numbers. So that's why we can term a stream as an iterator. And for you to be able to access those values, then you need to loop through the stream. So one way of doing that is using the asynchronous for loop. So you use the asynchronous for loop, which is commonly known as the await for. And to be able to use the await for, you have to add the async keyword here. And we shall talk about async await in the next session. But this is how you use the asynchronous for loop to process the stream. So it's generally a wait for, like if anyone has worked with the for loop, for int I in stream, so for every number in that stream, then we can print the I, and we'll print all those numbers infinitely as they come in. And the other way of now processing streams is using the listen method. And with us here, we have the same stream. If you can compare, so it's the same stream. It still uses the periodic method. So after every 2 seconds, we want you to emit a value, but before you emit a value, add 1 to it, multiply it by 2, blah, 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 and then put it in the sequence so that we can process it later. So like just for the purposes of output, if these were to output, then we expect it to output 2, 4, 6 as now the seconds pass on. And here we looked through the event, we looked through the data sequence, the stream, using the asynchronous for loop, and we print each number. Here we use the listen keyword. So we just use stream.listen. So listen is a callback for the stream that we created. And just like the other one, so it expects a value of type int, and you can do whatever you want with that value. So that's basically now like what happens with streams on top level. And on the next sessions, we are going to dig deeper when we get to the code labs. We shall handle each separately, and we shall now create streams like both in Dart and in Flutter. We shall explore on the different ways to create them and how to now process them. It's a very wide topic. We couldn't fit it in one session, but we are going to look at that. And here I've provided also some resources if you need to look at streams. It's a very interesting topic, and once you understand it, you'll actually get to love it. And thank you guys. So that's what I had prepared for today. So I talked with the organizers, and next on in our list of the async APIs, we are going to look at the async await keywords and how we can use them. We'll also look at generators, and we'll also look how we can initiate background processes while working with that. So that's it, guys. And my name is Isaac Mutia, and that's all from me for today. I hope I haven't taken much time, and I look forward to the next session where we look at the next ones. So I hereby hand over the meeting to Jacqueline Kendi so that we can take a few questions that will be coming in. Jacqueline Kendi, if you can hear me, back to you.
Yes. Yes. Thank you so much, Isaac. Thank you for the session. It was so lovely, and wow, thank you. I'm opening the platform now for anyone who has any questions. You can now ask. Oh, and for the guys who are asking to join the WhatsApp group, I think currently it's full. So just let me share the link to the Telegram group. But also, if you have any questions concerning the session, kindly ask. You can unmute your mic.
Okay, then maybe if there are no questions, then I'll promise immediately after this, I'll share the slides you have seen, and I hope we'll learn from them. And I look forward to the next sessions where we look at the remaining async APIs and also the code labs, where we'll get to explore each async API further, decipher everything from it, and we shall keeping on. Thank you guys for showing up. That's all from me from today.
All right, thank you so much, Isaac. I think also guys can also ask in the group. Danvik, if you can hear,
Hi everyone. I think I don't think I have anything more to say. Thank you guys for showing up. It's been a pleasure hosting you. I think that's all from me. I don't think I have anything else to add on. Thank you.
Yeah. All right. Thank you very much, guys, for showing up. Thank you, Isaac, for the session. I think everyone has something to say. Yeah. All right. Thank you so much, everyone. Yeah. So we can end our session right now because we consumed the 1 hour that we're supposed to have for the session. The next thing we'll continue with this and talk more about features and streams and what Isaac was saying, I see a question here. How do we match two or more streams to one?
So hi, Ben. So when you talk about merging one or more streams, so, okay, then I guess we also received a response from that. So there are several ways you can do that. And like Waga said, thanks Waga, by using RxDat. And also there are other ways to do that. And due to time, since it's a wide topic, Ben better allow us to tackle that when we'll be looking at the code lab for streams, and we shall explore everything on that. Please.
Okay.
Okay, thank you.
Thank you. If there are no more questions, we can end the session here, and then we wait for the next one. Thank you so much, guys, for attending. Always an honor. Have a lovely one.
Have a good one too.